we'll see what is linear regression models. We need to learn some machine learning terminologies. Features are attributes of the data. Features include all columns of data except label column. This is label column. So these are all the attributes of the data: sepal length, sepal width, petal length, petal width. Target is the column to be predicted. This is the column to be predicted. Features include all columns of data except label column. Label column include the targets to be predicted. So what is linear regression? A linear equation is represented as y is equal to w1x plus b. So y is the predicted label, b is bias, sometimes referred as w0. W1 is weight of feature 1. An example is a particular instance of data x. It is represented by row of the data. Labeled example includes both features and label. Unlabeled example contains only features. What do you mean by training? A model can be trained to find the best configuration. The labeled data is the input to the model. These are all the labeled data. This is the input to the model. This is the model. The labeled data is the input to the model. The output of the model includes both prediction and error. So the output has both prediction and error. Here error is fed back again through the model. The error is fed back to update the weights and biases. The objective is to get the best prediction accuracy from the model. The second step what we follow is inference step. Once the model is trained, we can provide new examples for predictions, which is so far unseen. This is the new data. It's fed back to the model. So this is the prediction. So we can provide new examples for predictions. In this example, the model is predicting a bicycle. What do you mean by loss? An ML algorithm builds a model with the best prediction accuracy. It improves the accuracy by minimizing the error. This process is called empirical risk minimization. Loss is the penalty for bad prediction. If loss decreases to 0, that means the accuracy has reached the maximum value. The goal is to find the optimum values of weights and biases. That leads to better accuracy with low loss across all examples. Now one more terminology. What is squared loss? The squared loss is found by the difference of predicted versus actual outputs. The square of the loss is squared loss. Evaluation metric. There are many metrics available to measure performance. For example, accuracy, how well predictions match true values. So the accuracy, how it matches the true values. The performance of the model is measured through the metric called accuracy. Accuracy shows how well the predictions match with actual values. The second metric is called mean squared error or MSE. MSE is the average of squared distance between prediction and actual values. How we can reduce the loss? Remember, the linear regression equation is y equal to w1x plus b. X is the input to the model, y cap is the output of the model. The squared loss is computed as the square of y minus y cap. ML algorithm examines this loss value and adjusts weights and biases to reduce this loss. Now again, output prediction and loss are recomputed. This process is reiterated till the loss reaches the minimum value. Now we can say that model has converged. This example, a linear curve is fit in such a way that the distance from the predictions are minimized. For example, when we start, the distance is more from each data point. This curve is fit in such a way that the distance from the each data point is minimized and the loss is minimized. The moment loss is minimized, the accuracy is getting increased or maximized. So over a period of time, the curve is getting fit. Iterative approach. This figure shows the iterative approach. The training process is iterative and illustrated here. The model takes features and labels as inputs and compute the loss. Based on the loss values, the weights and biases are getting updated. So it's fed back again. So based on this loss value, again weights and biases are getting updated. Again model recomputes the loss. This process is iterative. So this is repeated again and again. What is gradient descent? Gradient descent is the method used to calculate loss for different W1. For different values of W, the loss is computed. The weights are adjusted in such a way the loss reaches the minimum value. Here. The loss weight curve is convex. The computation stops at the point where the slope is exactly 0. At this point, the loss function converges. How gradient descent works? The gradient descent algorithm starts at some arbitrary point. The gradient of loss is equal to the derivative of the curve. The algorithm takes a step in the direction of negative gradient, then it progresses until it reaches the minimum. What is the learning rate? The gradient vector has both magnitude and direction. The magnitude of the gradient is multiplied by a scalar. This is known as learning rate. The learning rate determines the next point. If learning rate is very small, it takes more time to reach the minimum loss. If the learning rate is very big, then there is a chance of missing the minimum loss. So in this curve, you can see the learning rate is big while starting, then it gradually reduces, and then when it reaches the minimum, the learning rate is dynamically changed to a minimum value. So this is illustrated in this curve. So initially the learning rate is very high, then it reaches the minimum value, so that the minimum loss value can be reached. How the complexity affects the goodness of it? Sometimes the model is very simple, leading to underfit. Sometimes the model is very complex, leading to overfit. But we need right fit. Model optimization is required to arrive at right fit. Curve fitting problem. The performance of the model is determined by the right fit. During training, sometimes model gets overfit. So this is underfit, this is overfit, and this is well fit. But there is a tendency to overfit during the training. What is the solution? Splitting data into two sets. Data is divided into two sets, training and test sets. Training set is used for training the model. Test set is one model never seen so far. And used for testing the performance of the model. Train and test split. This example shows how training data is used to get a trained model in training phase. This is the training phase. This trained model is used with testing data. To predict the output in the inference phase. This is a simulation step where model performance is measured with test data. If model exhibits good performance with test data, then model can be deployed to handle real world data.